Hi everyone, my name is Yurii Paniv. I would like to present our paper, Setting up the data printer with improved English to Ukrainian machine translation, which I written in a team with Dmytro Chaplynskyi, Nikita, Trynus, and Volodymyr Kyrylov. The problem is that there is a lack of data for training high-quality Ukrainian or low-resource language models, and huge part of internet is machine translated using bad models, which lead to the same mistakes occurring during model inference. And our approach to tackle this problem is to create a recipe for training state-of-the-art machine translation models with LoRa to expand training datasets with English data. It consists of two steps. The first step is to validate noisy corpus of translation pairs from paracrawl using different data validation methods. And the second step is to continue fine-tuning on high-quality translated multi-30K dataset using k-fold perplexity filtering pipeline. Our target metric is BLEU. We've chosen BLEU score and on FLORES dataset for English-Ukrainian translation as a measure of our model performance. And the first phase that we've applied for training is heuristic filtering. We used the paracrawl dataset, which consists of 13 million sentence pairs and discarded 10 million pairs. The issues that we've identified is that there are repetitive, machine-translated, and low-quality samples in that dataset. So we've applied language filtering using GCLD3 library. We've applied perplexity thresholding with monolingual models. We've applied translation mismatch filtering using Lebesgue distance between source and target sentences, rewarding those translation pairs where source and target sentences were close to each other. And we selected total dataset size based on the thresholds above. And we trained the model on a resulting dataset on Mistral 7B version 0.1. And our best performing model was trained on a dataset of size of 3 million sentence pairs, which resulted in 30.37 BLEU score on FLORES devtest. Then we applied second phase and supervised data selection. We continued training on high-quality extended multi-30K dataset, but we used the k-fold cross-validation for perplexity evaluation of the dataset. And using the scores that we've obtained, we applied perplexity filtering and removed highly surprising sentences by sweeping the perplexity filtering thresholds. In the resulting dataset, selecting 17K examples out of 30K of the source dataset for final training. And as a result, we have beaten previous state of the art with a score 32.34 by discarding 40% of the extended multi-30K dataset. And another insight that we have found that by discarding 80% of the data, we've achieved nearly the same performance as with training on full dataset. And this means that by investigating as more efficient data selection methods, we can optimize our dataset size, not requiring as much training data as used for other language models. This is a resulting distribution of negative log probability scores for each data point in each fold. And you can see a tail of the distributions that we are discarding there. And there are a lot of highly surprising examples, which means that those translations were bad in opinion of the model. And as a result, we have state-of-the-art model, which achieves a BLEU score of 32.34, beating other notable models and services such as Google Translate and GPT-4 in 10-shot setting and GPT-4 Turbo Preview in 0-shot setting by Tublo and beating even previous state-of-the-art from Helsinki NLP that achieved 32.2 score. We've further tested our model on GPT-4o, and it achieves a BLEU score of 31.4, which is improvement over the previous one, but still we achieved higher scores than them. As a side effect, we found that even though our model was fine-tuned only for English-Ukrainian translation, it translates from other languages as well, even performing GEC task. GEC means grammatical error correction. And you can see examples of translation from French to Ukrainian, from Spanish to Ukrainian, and performing grammatical error correction for Ukrainian as well. We've noted that result, but still it requires extensive evaluation on various benchmarks to check what is particular performance we can achieve by training only on English-Ukrainian translation pairs. Also, we've investigated a few shot translation, and we've investigated beam search specifically, looking for sentences that achieve the highest BLEU scores in the resulting beams. And we found out that there were much better translations inside those beams, but algorithm couldn't select them, unfortunately. And we've gathered an insight that model already knows good translations, but we need a method how to extract them from that model. And regarding limitations, our model is fine-tuned only for single sentence translation. We've evaluated using BLEU metric on FLORES test set, and we've evaluated our BLEU score on VMT 22 benchmark. It's 24.72. Underperforming below current state of the art on that benchmark of 25.2. And we noted that submissions that score relatively low on the WMT 22 test scored comparably to our results on FLORES and vice versa, which means it requires further investigation how much different those two datasets are. And finally, we've contributed a recipe to build a translation system using a combination of data cleaning and unsupervised data selection, which is available on GitHub. And our model, Dragoman, achieves state-of-the-art performance on FLORES devtest set for English-Ukrainian translation task, achieving 32.34 BLEU. And we also released resulting dataset on Hugging Face as well. Thanks for your attention. Our online demo available at Hugging Face as well. You can access it there. Have a nice day.